Good morning. Thank you, Mustafa, and welcome you all once again to this session of on energy storage track. Uh, to begin with, we'll like to have a 2-minute video which we have prepared on E-Tech Next, which will give you an idea as what this entire E-Tech Next conference is about. So, Vivek, okay. So, in the meantime, while it's getting ready, let me give you a brief, outlook of the track. So, we have 5 sessions in all today. We begin with these sessions. Okay, it's ready. So, we play the video first, and I'll get back to you.
This 14th edition of Electrama, we have second edition of a track called E-Tech Next, which is going to talk about latest technologies. And within E-Tech Next, we have a very exciting track of electric mobility. We all know that electric mobility is the talk of the town, and the whole world is really looking at this as a new technology which is going to drive future innovations and cleaning up of the environment. In this track, we are going to host a lot of participants from fleet operators to vehicle manufacturers to startups to app-based aggregators and variety of other technologies like batteries and motor technologies and other things. So this is going to be the place where we are going to host a new technology innovation kind of a forum where we are going to all not only participate and contribute but also learn about many new things. In this, we are also going to talk about charging infrastructure, autonomous driving, and standardization of these products and systems. That we'll be having panel discussions on regulatory frameworks and policies. We'll be having presentations on different types of energy storage technologies. We'll be talking about the financing aspects, and we'll also look into how we can optimize the uses of all the technology from India, make in India, and have the effective localization done so that we have maximum contribution from the country to this segment. We will also have a session on the application and uses of battery energy storage system for different stakeholders.
Just to give a background why this has been included, we all know that the pace of the change of business landscape is more rapid than anything we have seen before. The technologies like artificial intelligence, machine learning is changing the way we live and we work, and which is in turn changing the entire paradigm of the business model. Now this shift in the change in the business model is actually demanding a lot of change in the skill set which is required by the workforce. Let's sing this in repetitive and precise knowledge will no longer be required. A report of McKinsey says that around 50% of these jobs are going to get automated. But then the fact is there will be new jobs which are going to be created along the way, but then these are going to be more focused on cognitive skills, which is more about creative thinking, problem solving, those which has to do with more empathy, touch with the human people. So this particular track is going to focus on how industry, government, and a strong drive from within the individual is going to help in creating that new upskill.
Techniques, we are having a course focus on innovation. Now, as we go forward in the emerging technologies, whether they are in the area of IT, when we talk about IoT, artificial intelligence, or in the area of mobility, when we talk about connected vehicles and the electric mobility, electric vehicles, e-highways, etc., the role of innovation cannot be underestimated. As we have seen, especially in the IT world, that the startups and the innovators and the researchers and the academia play a very, very critical role in building and bringing to the market the new technologies which the corporate world and the large corporates subsequently build upon and bring the products to the market. With this thought in mind, we have a track focused on the startups where we aim to do two things primarily. One, to bring the really innovative startups in this particular area to the platform where they can come and talk about their products, their solutions that they are developing, the technology areas. And the corporates can look at those, assess those as to what kind of technological directions are being taken.
Thank you, Vivek. So, catching up from where I left, we have in all 5 sessions planned for the day. We begin with the first sessions, which is on the policy and regulatory framework, where we have our panel discussions. Then we have got a session on emerging technologies for energy storage, followed by financing in energy storage. The post-lunch session begins with Make in India localization of energy storage components. And the last session is a joint session which we are having with WUS, and that session will be running on second floor in the main building, where we have got we're talking about the applications of energy storage. So we will request all of you to assemble in that hall after 3 o'clock for the final sessions for the day. So, not wasting much time, I would like to call upon the panelists of the first sessions. To begin with, I would like to call upon Mr. Stephen Fernandez, who is the moderator for the session. Welcome, Stephen. So, Stephen is founder and president of Customized Energy Solutions. Since Customized Energy Solutions founding in 1998, it has helped thousands of companies understand wholesale and retail electric and natural gas market and implemented solutions through its host of software platforms. Customized Energy Solution manages over 10,000 megawatt of assets, including over 200 megawatt of energy storage assets. Stephen has led the expansion of Customized Energy Solutions from Mid-Atlantic based energy services firm to one that provides comprehensive solutions throughout the US, Canada, Mexico, India, and Japan. As president, Stephen has focused on developing competitive wholesale and retail energy market and development of software that enables innovation in areas of retail competition, demand response, program development, supply procurement, generation development, storage integrations, and transmission congestion analysis. Stephen has a BS in economics from Pennsylvania State University and MBA in finance from Drexel University. Welcome, Stephen, once again. So our next panelist is Mr. Rupam Raja. Rupam Raja is Market Director of Fluence India and Southeast Asia. In his role, Rupam is responsible for the development of battery energy projects for grid-connected generation, transmission and distribution application, as well as behind-the-meter commercial and industrial applications. Rupam has successfully developed a portfolio of grid-connected battery storage projects in Philippines, providing frequency support services to the national grid. In India, he is supporting the operation and maintenance of 10 megawatt 1-hour battery storage project developed by AEH, Mitsubishi and Tata Power DDL, where Fluence is technology provider. Prior to Fluence, Rupam Rupam worked with an international environmental risk consultancy, and before that he was developing renewable energy portfolio for a private equity group for the global IPP. Rupam has a master's degree in international business from Thunberg in the United States. Welcome once again, Rupam. So our next panelist is Mr. Rahul Tongia. May I request you on the stage, Rahul? So Rahul is a fellow with Brookings India in New Delhi. His work focuses on technology and policy, especially for sustainable development. He leads the Energy and Sustainable Group at Brookings India and is also active in broader issues of technology. Mr. Tongia's work spans the entire gamut of electricity with focuses on supply options including renewable energy, smart grids which uses innovative information and communication technology to improve management of the electric utility grid, issues of access and quality, and broader issues of reforms and regulations, including electricity pricing. He is also an adjunct professor at Carnegie Mellon University and was a founding technical advisor for the Government of India's Smart Grid Task Force. Thanks, Rahul, once again for coming. Our next panelist is Mr. Anish. Mr. Anish, may I have you on stage, please? Mr. Anish is a director with Power and Utilities Consulting within Deloitte, Touch Thomas II India LLP. He has around 14 years of experience in advising clients in areas like corporate strategies, mathematical modeling, data dynamics, simulations, commercial due diligence, financial valuations, market assessments, etc. Anish has cross-country experience in Myanmar, Indonesia, Vietnam, Singapore, Nepal, Sri Lanka, Bangladesh, and Saudi Arabia. He is a graduate engineer from IIT Kharagpur and an MBA from IIM Bangalore. He has mostly worked with development agencies in addition to several government, private utilities, private equity funds, etc. Anish is presently assisting in program management, managing the USAID Renewable Integration Sustainable Energy, that's called RISE initiative. He is closely working with CRC and redesigning Indian power markets. He is also leading the modeling effort in analyzing the potential value and that battery energy storage brings in for the transmission and distribution utilities by collaborating with key states and distribution utilities. Anish also leads the EV chapter within Deloitte PNU services line. Welcome once again, Anish. Our next panelist is Mr. Rishabh Jain. So he joined CEEW in December 2018. The Council's new initiative CEF aims to reduce the gap between industry and policymakers by providing real-time analysis of market trends. CEE will expand its reach beyond Indian markets with a focus on emerging economies. Rishabh has been associated with Council since its early years. He has worked on both grid-connected RE and energy access projects. During his previous tenure at the Council, he was deeply involved in conceptualizing and designing clean energy access network. He has also worked with Vikram Solar, Energy Labs and Oxford Policy Management, where he is involved with senior management and government departments to overcome policy challenges. Rishabh holds a master's degree in public policy from Lee Kuan Yew School of Public Policy, National University of Singapore, where he was a Lee K. Shing Scholar, and University of St. Gallen, Switzerland. He also holds an undergraduate degree in mechanical engineering from BIT Meshra. So welcome once again all the panelists, and now over to you, Stephen, to lead the discussions.
Thank you. I very much appreciate the honor of being able to moderate this panel with very distinguished panelists and addressing a very important issue that faces not only India but across the world of how do we properly integrate in the renewable assets that we have, as well as create a more sustainable energy ecosystem in a financially viable manner that's inclusive to all of our citizens and looks to promote a more efficient use of the energy system so that we are not using the most expensive generation resources to do the least valuable work on the grid. But we are looking to use the right resources to provide the right services that our consumers and that people are looking for. So my background, as was mentioned, was a little bit on regulatory change. So when Customized Energy Solutions started back in 1998, it was the start of deregulation in the United States. India, in many ways, has jumped over the United States in that it has an energy market price day ahead across the entire country, unlike the United States, which has it only over about 60% of the population. So India has also progressed enormously in solar energy and in renewables overall to become one of the leading countries in new solar and new renewable energy. But with this has come a lot of challenges. Deliverability has been problematic in certain parts of the country. We've seen a need for more electricity in rural communities and rural areas, which is something that is important to me and important to our company. And so I'm really looking forward to this panel to explore sort of what the policy changes need to be, what things need to happen to get energy storage to go from presentations and initial projects to a large-scale viability across the country. So to start us out, I thought I would give a few minutes for each person sort of go through and describe a little bit of where they see their vision for energy storage and this industry. And so, Anish, if you can start out, and then we will just go down to just what you see as being the policy changes and where the future of energy storage can and should be in India.
Right. I think to start with, a few years back, there was no talk around energy storage in India, but slowly we realized that we need to achieve a story which is like we need to integrate 175 gigawatt by 2022 and say 450 gigawatt by 2030, if that's the number which has been projected by CEA. So when there have been a lot of studies which have been going on, there have been a lot of modeling which has already been done, and everywhere it has been kind of coming out very clearly that India requires that balancing support to integrate these large volumes of RE. And therefore, storage becomes an integral part of it. Now the question was whether the price point what storage comes in, that was the right price point, which can actually become a credible source for balancing, or there are alternate mechanisms other than storage also which can actually do that. So there is a study which was published by NREL which said around that greening the grid pathways to integrate 175 gigawatt. They said that if you bring it down the technical minimum or by 50% or 55%, then probably the curtailment comes down to only 2%. And therefore, Government of India started thinking that flexibility of coal is one such measure which can actually balance it. But then if you do a dispatch simulation for, say, in 2030 time scales, so even with flexibility, we would require some amount of storage, and the optimal, probably the solution is not that you do 100% of flexibility and be the optimal storage. So therefore, at different price points of storage becomes much more viable. Storage becomes the only, probably, I would say, credible resource which comes out as a very, I would say, important or critical factor for balancing resource. And to support that, Government of India and the policymakers as well as regulators have recognized the fact. If you see the draft changes which has come out of grid code also, they have said all resources is a must-run resource and you cannot curtail it back unless and until you have actually used all alternate measures, including of storage. So they have started mentioning storage in all the policy documents, all the regulatory. We know for a fact we have been working with CRC in ancillary regulations as well. So earlier the discussion paper never mentioned about kind of storage procurement. It would be a competitive storage procurement, and never mentioned about technology agnostic procurement. So what we know for fact that there has been discussions around that there will be of course competitive procurement of ancillary services, but it will be technology agnostic, and probably the I'm saying resources which are fast responding can be also incentivized. So these are some of the, I would say, discussions going on and still at deliberative stage. So it's that I think policymakers have realized that storage is required. Probably just that what is the correct price point where we adopt that storage in all our wide scale kind of usage. That is one. Second is there is a Niti Aayog program also, which they have been planning for gigafactories, and they have been I think already a cabinet note has put that how much of budgetary allocation or what is the plan for making India storage. So there also they have just initiated a study which again we are doing for multiple states in assessing how much storage requirement is for multiple states. From the power side mostly, means both in the intra-state transmission corridors as well as for the distribution end. If you do a modeling kind of thing, so what is the requirement or optimal requirement of storage, and what is the optimal locations across the grids where storage can be placed. So these are some of the studies which will directly be an input to decision making or to the policymakers for coming out with larger kind of policies or regulations. So I'm saying there's a lot of actions going on, but probably I think Rupam can help us with the fact that how is the cost structure going to come down, because when we do those analysis, there's a lot which depends on the cost. At various levels of cost, the analysis completely changes. So the quantum of storage which I'm saying, requirement changes with cost. So if the cost is say 30% lower than what's today's cost, then it becomes absolutely viable for all the DISCOMs or for all the, I would say, interstate transmissions to go ahead and procure storage. But if the cost is remained to stay at today's cost, then probably the viability is not coming out in certain cases, I would say.
Thank you.
Morning, everyone. First, I want to pick up on a point Anish said, which is very, very important. The short run and the long run, long is a term economists like to use, in the long run, are a little different. 175 gigawatt of RE is mostly manageable under the current frameworks with not so much storage of time-shifting arbitrage necessarily required. But it is absolutely impossible to talk of those larger 2030 numbers, 450 gigawatts, for example, without a decent amount of storage. For a country of 365 gigawatts of installed capacity, our load met at a grid level fell after Diwali to under 100 gigawatts. And if you want to see how this plays out between different sources, I invite you to check out a website we've created at Brookings India, my institute, called carbontracker.in. So it's a real-time 5-minute resolution of generation by type with historical analytics visualization and carbon emissions real-time. And that's the real challenge. First, on the policy level, is for too long our policy did not differentiate between kilowatt and kilowatt hour. And they just used a static multiplier and just assumed that these are fungible. That's the first failure of a lot of historical planning. We are surplus or pseudo-surplus parts of the day. And that's where the value proposition really becomes more apparent for storage technologies. Now, what is storage worth? The first problem is a lot of people say, what does it cost? And instead, we should fix our thinking towards what is the value proposition it provides as opposed to the rupees per kilowatt hour. How many of you run storage or backup power where you live? Okay, let me reverse it. How many of you have zero backup power or storage? 5, 7 hands. How many of you are in Delhi? Yeah. So the Delhi people don't need it as much. How many of you outside Delhi or Mumbai have zero storage or backup? Okay, some number of hands went up, but still a minority, 20% less or 15%. So we're already paying a premium for diesel, for batteries, for inefficient lead acid. And so there is clearly an enormous value proposition, and the question is, who puts up storage for what uses? Time shifting solar is sort of the holy grail or the long-term need. The lower hanging fruit is already viable, which includes what you mentioned, some of the support services that storage provides, ancillary services. Today, the the regulations don't allow batteries to play in because the design is such that the surplus capacity of coal is how you're going to do a lot of the flexibility. What we actually need is policy that says all of the above. We should never pick technology winners. We should just price properly. And the first missing need in all of that is time of day pricing. Stephen, you mentioned India has a market. That power exchange is only 4% of the energy in the country. So time of day signaling is minuscule on the wholesale level. It is even smaller on the retail level. So those are a change that is needed, changes that will take a little bit of time to propagate. But once I signal correctly, then I'm going to get storage, I'm going to get demand response, I'm going to get load shifting like putting pump sets from the middle of the night to the middle of the day, then you avoid storage, and that's okay. That's probably even better. So it's going to be a little bit of all of the above. We just need to signal correctly. Last point I'll throw out there, I don't buy the argument, we'll come back to the numbers maybe, that a 30% reduction in battery pricing is going to get you viable time-shifting arbitrage prices for, let's say, a solar panel where half your energy has to go through a battery. We're nowhere near that number. But that's okay, we won't do half in the short run. Even 5-10% is going to be meaningful in material. But we're nowhere near. And we can debate numbers and technicality. Because I'll give you a small little sheet that I tell all my students. Here is the answer to every public policy technology question. It depends. Now your job is to figure out it depends on what, why, how, etc. And that's where the richness of this dialogue is. Thank you.
Yeah, so I'll give you a little bit more of a project developer's perspective to that question, in addition to what Rahul and Anish have just said. So, I think from a policy point of view, I think the action is, where we need more action is more on the regulatory side. I think what we need is, I'll give you the example of the Delhi project, right? I mean, the policy framework 2 years back when they envisioned the Delhi project was worse for storage than it is today, right? And the project still happened, right? So there was some kind of a policy approval to, yes, go ahead and do that project and we'll see how that works, right? So I think on the policy side, I think we have to get more projects on the ground. If I had to ask for a couple of things, I would say, the tax structure is very high. Right now, if you do a battery storage project, you could end up paying up to about 30% of the project cost in taxes. And I think that's something that the policymakers could address and lower that number like they've done for electric vehicles. They could do that for stationary storage as well. And I think the second thing that the policymakers can do is, there is no economy-wide goal for battery storage, right? So we have some reports, the Energy Storage Alliance has come up with a report that makes a recommendation. But quite like the government of India adopted economy-wide goals for solar and wind, and then the country was very successful in hitting those numbers, I think we could see a a scenario where the government declares a similar goal for the economy for battery storage, and the industry then gets into its act and gets us to that level of storage, right? I think that's what's needed on the policy side. But like I said, I think there's more action that's needed on the regulatory side to make more progress on stationary storage. And quite like what was done in the Delhi project, I think what's needed is, what happens when you make a procurement in the power sector, right? You express a need, you run the numbers, and you make a request to the regulator to buy an asset, right, that they're going to capitalize, and they're going to use it in your power infrastructure. That's the process, right? I think where we are stuck right now is that because the regulator does not feel comfortable if the regulated entity is paying the right price for storage or not, they end up just sitting on that and no decision is made, right? I think what we need is people in Bangalore to submit a recommendation to their regulator for battery storage and let the price discovery happen. We want people in Mumbai to do the same thing. We want people in Calcutta to do the same thing. The more such, asset owners, distribution companies, transmission companies, make recommendations for storage and go to the regulator, and the regulator then starts off the price discovery process, I think that's what's going to take to get more storage built into the Indian network.
So just a quick follow-up to that idea. I fully agree. One is nobody knows what the right number is because it's evolving. It's like a mobile phone. Can you tell me what it costs? Because next year it's going to change. So we don't wait forever. There's one small counter that will help this, I think, is it's not just to get liquid competition on the supply side, but also to do a netback calculation to the value proposition. So if I want a certain level of reliability, hypothetically, then I know need to pay more. And what are my alternatives? So I compare it to diesel, I compare it to a coal. So if I need to do a 5% peaking, I'm not going to build a coal plant to do that. I may not even run gas. Maybe I'm going to run battery. And so the netback calculation is another thing I think we need to do. Opportunity cost or so forth, that will help the case in addition to what you have just suggested.
Thank you, Stephen. So most of the points have been covered by the panelists, but there are a few things I just thought I'll touch upon. So one, of course, it is important to understand what the applications of storage will be in different parts of the grid. We may or may not look for the right number in the first place, right? With solar, coal, thermal, it is important to have that number because we know we would require certain kilowatt hours or certain units of electricity to be produced. But for storage, that number will keep on evolving depending on what is the infrastructure of various discoms, how is the infrastructure of various transmission lines, or even what is the infrastructure at various SLDCs, RLDCs, and hence these numbers will vary a lot, will be very dynamic, hence we may or may not look for that right number. Secondly, I think there are a lot of innovative things that we can do with storage that we often discount because most of the times when we think of storage, we have started thinking of it as complementing just RE, right? Instead of that, storage can play a very important role in making the grid smart in the first place. When we add, say, smart inverters and smart meters to storage, then the possibilities are limitless, right? When your storage system can then actually have conversations with the grid in the first place and then supply back to the grid itself when you require. So it's not that every rooftop system, say if you have rooftop plus storage system, will always be supplying power to the grid at the same time. With TOD tariff, again, all these regulations will then incentivize people to set up storage and also maybe help them, incentivize them to set up smart meters in the first place. Because the government, of course, has plans for smart meters, but it's very difficult to implement them for whatever reason. Of course, at times those meters are not even smart enough. But in theory, say for example, when you have all these things in place, then consumers will itself or himself will be able to supply back, and then the peak shifting, time shifting, saving of electricity, curtailment, all of these things can also be taken care of. So in addition to all the points that have already been spoken, there are additional application of storage that should be explored and will be explored in coming times.
Thank you. A lot of good information there. One of the folks that actually has built a grid storage, Rupam, yes, I know from your earliest days building storage, some of the comments that were made is it wasn't originally for renewable integration. Actually, some of them was to be able to use your fossil units more efficiently by actually co-locating with storage for regulation and other requirements. I'm curious, I understand a lot of regulators are about to see your site, and I'm curious to find out, based on their feedback, based on your initial experience here in India, where you see sort of the next challenge to scale, and if there's any lessons learned from those visits.
Right. No, sure. So, so the regulator in India, in fact, our experience in India from a regulatory point of view has been that the regulator here is a lot more proactive than some of the other countries we are working at. Surprisingly, and I think it's India's, the technology leadership and the participation that India has in the technology space. I think that kind of an open mind to new technologies kind of spans across the government and I guess the policy making level as well. So having said that, so we have taken many regulators to the site. I think last count, we've probably taken about regulators from about 16 different states to the site. And I think the point that Anish made earlier, what we are seeing is that there is a clear understanding and acknowledgement of the need for battery storage. And there's a clear acknowledgement and understanding that this is something that has to be done, right? So that wasn't there 2 years ago. I think with the plant in Delhi, I think we've gotten that past that point. So I think from a technological proof of concept, it's a done deal, right? We don't have to fight that battle anymore. I think the point that Rahul made, right? So storage right now will not make sense in a lot of instances where we think storage will make sense. It won't. For that matter, it may never make that sense, and that's the point that Rahul was making. It may never make, at its price point, make sense where you say that I'm going to, charge my storage with solar, and I'm going to run an entire city all night on battery storage. That may never happen, right? That may never happen. Because at the end of the day, it's not generating any energy of its own, it's just adding cost to the generation that you have from whatever source, right? However, having said that, there are many instances where storage makes commercial sense right now. As long as you're doing the right comparison, see, the PPA structure that we've traditionally had in India, all the costs that you're actually paying are hidden in that one tariff that you sign up in your PPA, right? And that hides everything, right? So if you kind of split that up, you will realize that there is some things are cheaper than the PPA price and some things are more expensive, right? For the more expensive things, if you were to replace that with storage, it makes commercial sense right now, right? So I think what the regulators need to do is, and I think that is the price discovery process that I'm talking about, right? I think for those instances, we want distribution companies, transmission companies, generators across the country to prepare your detailed project reports for those instances and make those recommendations to the regulator to allow them to put in storage in their network to replace what's a very expensive part of the network right now. I think that is what is needed, and I think there are proactive regulators in this country and there are not so proactive regulators. There are enough and more proactive regulators who are waiting for such applications to come in. They will work through them and they will, and as needed, they will grant approvals to such projects. I think that's what's needed.
Yeah, can I make a point?
Thank you. Yes.
Just to add to that, what Rupam highlighted also that currently also storage makes a lot of sense in several applications. So there have been already kind of, I would say analysis already been provided to the regulators also that in current times the storage makes a lot of sense in applications like, say, for example, primary response or secondary response in the ancillary timescales. what we have currently is 5% of all the installed generation connected to the grid is kept as a reserve for providing primary reserves. And they're not participating in the market, so 5% of your capacity is actually reserved and not participating. So that's a kind of cost which the system is incurring, right? So instead of that, if you keep a storage and let it be used in primary and ancillary timescales, so what would be the cost comparison? So those models have already been done and it's been proven that storage makes sense. So there are applications where storage still makes sense. There are applications in the distribution timescales also saying, for example, if you actually want to use storage in reducing your penalty for DSM, additional penalties as well as sign change penalties, then probably there is a commercial sense. But over there, the capex requirement has to be done by the discoms and not really by the regulator cannot approve that capex. So there are those kind of trade-offs which you need to understand, and therefore storage, I guess, application-wise needs to be treated separately.
Thank you. Rishabh, I was curious, I know you have been active in many, many different countries throughout Asia and looking at sort of best practices of what people have done with energy storage, and in particular trying to make an overall more inclusive energy system, whether that's in rural areas or in areas where there's not very good reliability. I was curious if you'd just share some of your global research and just where you've seen, where you think India could learn from other countries and other markets in the energy storage space.
So, Stephen, we have not done a lot of work on microgrids globally, but specifically if you talk about microgrids in India itself, there's a lot of storage applications, at least microgrids which have been installed in India, which are mostly based on lead acid batteries itself. Unfortunately, we have not seen a lot of microgrids because, again, missing of certain market signals or the right policy measures which have not led to, say, setting up or deployment of a lot of microgrids in India. And most of the microgrids in India, unfortunately, are based on lead acid batteries only. However, in the last couple of years, we saw a lot of telecom towers being started using lithium-ion batteries. Sometimes they were successful, sometimes not. They also had the mixed feedback on the batteries. Also, it was because of the sizing, the availability of electricity in these telecom towers. But we are still seeing a lot of, lot of interest in these telecom operators to set up these batteries. But at the same time, they're doing it because it makes business sense to them, right? This is also happening because the cost of diesel or transportation cost of diesel on site is very expensive, and there's a lot of theft. Availability becomes a challenge, and because there's a compulsion by the government to provide, or there's an uptime of 95% or 99%. There's a very high uptime, and hence they have to make sure that the telecom tower is running. Something similar is missing for the electricity sector, right? If you don't have enough electricity, you can just have a blackout for maybe few time blocks or maybe hours, right? Because the discoms are not penalized for any shortfall of generation that exists in their region. In case, if we start penalizing them, or discoms have to provide 24 hours of electricity, or even say 22, 23 hours of electricity, that is when we'll start seeing more storage application where discom looking for innovative business models to set up storage either at the distribution or at the consumption level. So those similar signals are missing in the electricity sector, which are already there in other sectors where storage is being deployed.
Thank you. And you bring up an interesting question about distribution companies and sort of their incentive structures in their areas. And Rahul, you and I have talked about this before, about distribution companies and the role that they play in energy storage. And just what policies or things can be done to try to improve the situation with distribution companies so that more companies have the financial backing to be able to invest in new technologies and invest in energy storage.
So I want to start with Rishabh's point. It's really hard for storage to compete if your net back is load shedding. So as long as you're allowed to switch off, then it's really hard to be cheaper than that. So the first sort of thing is, as I've joked often, India has the most effective demand response program in the world. Unfortunately, it's not voluntary. And so the first thing really needed is different way of thinking and enforcing quality. On paper, there's a lot of laws. The data don't match what official data are. If you do bottom up, states say 100% electrified, and yet when CEW and ISEP and others have done surveys of 10,000 rural homes in a state, about 10-15% of people say, no, I don't have a connection. So that's one problem. The second, before we get to the financial, is to just step back and ask this question, who is the right person to put up storage? At one extreme, we already have a lot of the endpoints putting up storage or diesel for reliability. And that's a very expensive proposition. At another extreme, we've had this view that why isn't it the burden of the generator? And you could also just say that every solar panel needs to have some battery with it, which also may not be the only way and not correct. My sort of view is I shouldn't need to care as long as I signal the pricing correctly, whether it's the middle layer, whether it's the glue that brings these two sides together. And very honestly, it need not be the DISCOM. It could be a third-party storage as a service, STAAS. Because now that person can do statistical multiplexing or diversity multiplying, so that I don't need to put 5 batteries for 5 sets of paying customers. 2 is enough because you assume not all 5 need that storage at once. So once we get the signaling right, and we allow, right now the law does not allow me to be a storage service provider. So that's the first thing missing that needs to get changed. Then the DISCOMs, they need to be part of this conversation that allows these new entrants to create more dynamic bidirectional flows of power, whether that's storage, EV, demand response, all of the above. The entire relationship of centralized top-down one-way flow is another mix. So today, look at the Electricity Act 2003. It mandated open access above 1 megawatt size consumers. How many consumers or what fraction of India's load is open access? Very small compared to the load that's above 1 megawatt. Similarly, renewables rooftop is allowed. But in both cases, you've got this slow mentality from DISCOMs who resist something that hurts them financially. And so what's really needed is, as we rethink storage, we need to make sure that these prices are honest, that we're not socializing it in the inefficient manner. Otherwise, DISCOMs will resist it because they either lose their paying customers or it passes on the cost somewhere else. And that's a recipe for a slow uptake of what would otherwise be a viable technology.
Thank you. And Anish, I'm curious if you want to expand upon some of the challenges, as was mentioned by Rupam, that we don't have the same standard and focus on storage that we had with solar goals, national solar missions, national wind targets. In terms of the policies behind storage, I know there's interconnection issues. How do we actually increase penetration? What are the top couple of policy changes you think that could happen to help storage get to the level of success that we've seen in other technologies and other national efforts?
Right. So I think there has to be a holistic approach when I say a policy drive can happen for renewables alone. So, say for example, the policy to have, like California had, so say for example, 30% or 50% of their entire electricity needs has to be from renewables. So these kind of a policy target gives a clear mandate for all the stakeholders to necessarily align with that policy, right? So once you have that kind of a target, storage is just a tool which helps to or which enables that kind of an environment, right? So if you have set aside a target of 50% of electricity or 30% of electricity by 2030, 2045, then storage will definitely enable that to happen. That's one. Second is what probably Government of India has correctly understood from the solar story, that there needs to be a focus right now on the Make in India approach, and therefore there has to be a policy in actually augmenting that. Entire value chain needs to be through the Make in India approach. So they are working on that. So that's a separate policy which says that there will be a demand for the storage, both from the EV perspective as well as from the grid perspective. So why don't we actually see that most of the value chain can be captured through Make in India? So that's the second. But from the purely kind of, I would say, electricity point of view, I would say renewable, looking at the cost, looking at whatever, I would say, policy drives we have, there needs to be a set-aside policy that it's going to be the, I would say, renewable needs to be the way forward that everyone has understood, but 30% of our electricity needs to be met through renewables. That kind of a strong vision or policy needs to come. That's one. Second, on the interconnection, I think there has been a lot of successful case studies which has happened in US as well as in other parts of the country. So if I correctly remember, IEC 1547 clearly outlines the connectivity standards, what's going to happen, and this talks about how not only about the integration of storage in the grid, but also about interoperability of distributed storage with the utilities. So these kind of adoptions or this kind of, I would say, standards can come. What storage can also provide is, of course, the local voltage support and reactive support. So making it mandatory for inverters and storages to provide that when needed is one policy support. Second is, again on the reserves, there has to be a regional market or there has to be a state kind of procurement. So automatically the distributed storage or distributed all DRs can participate in that reserves market. So that these are a multi-pronged approach which can obviously contribute towards the, I would say, the path forward or way forward for storage to pick up.
Excellent. Before asking more questions, because I wanted to leave a little bit of time, and I think I just have a little bit of time, for any questions from the audience. Yes, please. Here, I will give you my mic and I'll share.
Thank you. Myself, Vinod Kotra from Secure Meters Limited. I thank you for everybody to provide valuable inputs. And I have one question with Mr. Anish, and I agree with many of the points with Rahul said. So what I see is there is a lack of clear picture on how we want to dispatch our resources and how we want to utilize the non-renewable resources in optimum way, and then how we'll put the storage. So I see in overall thing there is a lack of clarity. First, if I start with the central dispatch, so because Anish is working with the CERC, so when I see in the merit order dispatch, if I go to the merit.in portal, I see the least cost coal generation is in the highest merit order, whereas the non-renewable is in, though it is mentioned least run, I doubt whether it is dispatched on the merit basis or not. This is first thing. Second thing is that lot of PPAs at the state level is with the coal-based plants, and they are also not dispatching many states the non-renewable on the merit order basis. Third thing, the substation operator, at that level there is no merit order dispatch. Though in some states the agriculture feeder, the renewable injection is happening, they are doing, but I think at the substation and also there should be merit order dispatch and must run status should be given to the renewable. So when you give a merit order dispatch for the must-run non-renewable resources priority, then your maximum of the resources of non-renewable will be utilized at different level. And at the consumer level, already there is an inverter-based solution, so already it is automatically dispatched. So whenever there is a renewable energy available, the inverter already dispatches the renewable energy. So I think first this should be very much made clear how the policy should be framed in this manner. Second thing is that Rahul was saying at the peak load, we may be adding some storage and all those things, but at the peak load first we should implement the TOU. So we are...
So we probably want to handle those questions before any other ones.
Yeah.
So I think I got your question. So the question to you all is on, as I rephrase it, is about rank order or merit order dispatch and how we're doing dispatch, and zero marginal cost generation, that should take preference over fossil fuel generation in the dispatch queue down from the top.
Right.
Good. Cheers.
Thank you for the question. See, I think due to the legacy issues, India is grappling with some of the issues which you have highlighted. They have long-term contracts, no denying of the fact that if you don't dispatch, there is a fixed cost associated with that. So there is a resistance from the generators, at least the state GenCos, in saying, or the DISCOMs, in saying that, of course, you are incurring a cost and therefore you are making it a must run for the renewables. So the cost is increasing. And there are a number of states we have represented to FOR and CRC saying that in parallel, please assess our cost of integration of renewables, and we are 100% sure, or we are sure that this is much more than what has been probably worked out by CA. But having said that, I think the central government and the CRC has set out a way forward, which is very much, I would say, in line with what international practices are. There is a central merit order dispatch which has been talked about, MBD. There are, of course, practical challenges in implementing that. We are working on that. I think the states need to also probably work in parallel to make it happen. But I guess most of the states are doing a fair amount of merit order dispatch. They have already, I think, acknowledged that renewables is a must run, so they're dispatching renewables first and then probably stacking up the merit order in truest forms. There have been certain cases where curtailment has happened because of technical challenges, what they have outlined. But yes, I think that what has been outlined in the grid code, at least in the draft version, it makes it very, very difficult for a state to now back down renewables, because they have been saying that, or they have outlined that it's a must run under no circumstances, or only on extreme circumstances you can back down. So I would say these are some of the enablements which needs to happen and which will happen. Renewable is the way forward. Everyone has understood that. I think there is a huge amount of system cost savings which everyone has recognized. Policymakers have recognized. Nobody is denying the fact. So now it's like, once renewable is a base load, or it will become a base load, how can we actually design the system to make it happen? So first of all, how US has done it is make renewables dispatchable as the same as what conventional is. I think that's where we need to go there, right? So renewables also come to the market the same way as a conventional plant comes. So you reduce your FNS deviation bands from 15% to 8%. First of all, allow the rest of the deviations to go for the renewables, or allow them to come to the market. And then probably the balancing cost needs to be again allocated to all the DISCOMs or all the load serving entities. That's the way the US has gone about. That's the way I would say the policymakers are thinking about it. So I think no denying of the fact that renewables is definitely the way forward, and conventionals and all other systems is going to be surrounding that, and therefore making a way for renewables going forward.
So Rahul, I will give you the final word here, as I think I'm getting...
My second question is this.
The signal.
Yeah,
sorry, I'm just going to let Rahul finish. So sorry, we definitely offline, if there are questions afterwards, we definitely can handle them. Rahul, any final words for the panel?
So I think we have to remember a few things. Coming back to your opening points, in the short run versus long run are two different things. In the short run, one would say whether you call renewables must run or you just say look at the marginal costs, should both in theory bring you to the same answer. But the problem is not just the bad contracting or PPA problem. But if I'm a state and I look at a portfolio cost and say time of day I still need that coal plant, the variable cost for my coal plant on Pithead is 1.5, and now someone's saying at 3 I need to go buy renewables. The math doesn't align. That's one challenge. The second thing that's missing in this discourse is the locational spread. You look at the plant load factors of India. Everyone who says, oh no, coal is dead, its PLF is falling, ignores the fact that your 60% PLF is a bunch of 85s and a bunch of 45s. And so that's another key issue to where and how much storage you're going to need and how these technologies are going to evolve. And so in the short run, if I've got so-called surplus capacity of coal, then it makes sense from a lot of narrow lenses to just say, let me use that at the margin instead of building a new RE. Once built, an RE will dominate coal for sure on the margin. The question is, we're not just talking about existing RE and existing coal, but investment decisions, which gets to the risk issue that are we just passing on all these costs contractually and how? So these are some of the conversations I think the government and policymakers need to grapple towards. And as long as we recognize this heterogeneity and allow, I've had auditors say, oh, this electricity is 7 rupees a unit. No, very costly. And I'm like, yeah, but you're only using it for 2 hours a day. So it's this portfolio approach that's needed where storage would have disproportional value, I think is the way forward.
And can I add a point to that? Yeah. So I just want to kind of apprise the group of the audience here of something very important that's happened over the last few weeks, right? So we had a tender close on the 15th of January. It's for 1,200 megawatts. And it's a solar wind hybrid. But you have to supply power in the peak hours, right? So it has 2 hours peak hours in the morning and then 4 peak hours in the evening. Now earlier this tender was structured as a round-the-clock tender, so there was no definition of when that power would be demanded, right? So people were structuring, solar wind with storage, and of course they were adding a lot of storage to it because that's the only way they could guarantee RTC, right? And then I think they thought about it a little bit more, and then they reduced the peaking power to just 6 hours during the day. What you've seen that has emerged, now the tender closed a couple of days back, right? What you've seen emerged is that people have gone and found the best solar and wind sites, okay, where you have solar during the day, and then you have a lot of wind during the night, and they've tried to minimize the size of storage in that mix, right? So what they're trying to do is they're trying to get this optimal mix of a site that can produce RE, which is the cheapest available, and then in the holes where you don't have RE available, they've tried to size storage. So you will have, so number one, I don't think it makes a big impact on the size of the storage per se, but what it does do is it does not cycle the storage as much. So you'll have batteries that will be using like 50 days of the year, and therefore that batteries will last you 25 years, right? So you don't have to worry about replacing the battery anymore. So let us see what happens out of that tender, and if that tender is successful, then SECI will turn around and sell that peaking power to the DISCOMs at a price that's lower than wherever they're buying their peaking power from right now for those 2 hours of the day, right? And if that happens, I think that kind of changes the tide, and then we are talking about dispatchable RE, and that's when you're talking about truly, RE replacing, some of the other fossil fuels that we have as an option today.
Thank you very much.
Thank you, Stephen. So I'll just take forward what Rupam said, and if you notice, there were a lot of ifs in it, and this is the biggest problem with storage in India, where SECI and other organizations come up with tenders and then they get cancelled. So instead of the right market signals, we are getting negative market signals. We need to immediately stop that. The government at various parts of the grid needs to set up few storage projects, and of course there will be multiple benefits. At the end of the day, we may see it's just a small project, but of course we'll get experience, we'll be able to build human capital and also a lot of data points. But in addition to that, if we really have to say set up storage and if we really want the grid to be more smarter, there are certain policy decisions that the government should take, starting from tariff rationalization. But again, there are places in various parts of the grid where you say the DSM penalty, say for RE power projects, increases. Right now it's of course very small, 50 paisa, 1 rupee, though it's, when you compare to the percentage of PPA tariff, it's high, but when you start penalizing people and they have to supply a power which they said or which they promised, then storage we'll see storage being deployed at solar and wind power plants. In addition, when you have TOD tariff at the consumer level, you'll see people then maybe consuming or storing power in daytime when there's a lot of excess capacity or generation available, and then using it at later stage. So these market signals will automatically lead to designing of new business model which will deploy storage at the price at which we penalize or incentivize people to set it up. Thank you.
Well, I want to thank all of the panelists for all of your contributions. I think that energy storage has a bright future in India, and with all of our work, I think we will get there much sooner. So if I can get a round of applause for the panelists.
So thank you, Stephen, and all the eminent panelists. So now I request Mustafa. Okay. So I'll request Stephen to hand over the mementos to the panelists. So starting with Anish. Yeah. Okay. Then Rahul. Thank you. Mr. Rubam Raja. Thank you. Yeah, right. Mr. Bishop Jain. Thank you. And now I request Mr. Mustafa to hand over the memento to Stephen. Thank you. Thank you once again, everybody. So we start our next session.
Gaurang, where are you? Please come on stage. They want to take a group photograph. Sandeep? Yeah. Aye, please.